All right, this afternoon we are talking about matter, and in particular we're talking about subatomic in matter. We've already mentioned this before, and I'll have the better PowerPoint put up on the website. This PowerPoint, it's cutting off some of the pictures and diagrams, visual aids there for you. So, but if you go to the website, to my website, and you click on the PowerPoint, you'll be able to see the whole image. But this is just showing us what the different subatomic particles are. We have neutrons and protons that are inside the nucleus. Protons, remember, have a positive charge. Neutrons have no charge. And then we have electrons, which have a negative charge. Okay. The atomic number on the periodic table tells us our number of protons. All atoms of the given element have the same number of protons, and so that's what we call our atomic number. It's usually listed at the top of the periodic table. And again, I don't know what's wrong with my slides, so let's just look at the part that's circled here. Isotopes are, by definition, they're elements with the same number of protons but different numbers of neutrons. An element is identified by its number of protons, so you don't ever change the number of protons, but you can change the number of neutrons. So hydrogen, for example, can have 0 neutrons. It can have 1 neutron, and that would be deuterium, or it can have 2 neutrons, and that would be tritium. Helium can have 1 neutron, or it can have 2 neutrons. Lithium always has 3 protons, no matter what, but sometimes it can have 1, 2, 3 neutrons, or it can have 1, 2, 3, 4 neutrons. So those are just 3 examples, and almost all elements in the periodic table do have isotopes. It means the same element, but a different number of neutrons. Mass number is the number of protons, and here we go. It's the number of protons plus the number of neutrons together. That is our mass number. And this is our abbreviation for how we write that. We can write a chemical symbol for the element. Let's say we have nitrogen. The mass number is going to be the number of protons plus the number of neutrons. So if we have nitrogen 14, that means we have 14 protons and neutrons together. And then at the bottom, we always write the atomic number, and that's just the number of protons. So that would be 14 on top, 7 on the bottom. If we did boron, if it has a mass number of 11, then its atomic number would be 5. You put 5 at the bottom and 11 as a superscript. Okay. Carbon 12 has 6 protons and 6 neutrons, and that gives us carbon 12. It has an atomic number of 6, or 6 protons, so we put those in the bottom. Also need to remember that whatever number of protons you have the same number of electrons. Average atomic mass. Average atomic mass, by definition, it is the sum of the protons and the neutrons. Oh, that's mass number, sorry. The average atomic mass, on the next page, is the weighted average of all the isotopes of an element. Weighted average of all isotopes. Okay, so when we talk about weighted average, that's taking their percent abundance into account. And percent abundance, when I use that word, I'm just talking about how much is present naturally. The amount of the isotope present naturally. So if I look at magnesium, for example, and again, I don't know why it keeps repeating like that. So we're just going to look at one. Okay, so let's say magnesium. Magnesium has this average atomic mass of 29.31. That is the weighted average of all of the natural isotopes of magnesium multiplied by their abundances to get the weighted average. So magnesium can exist in three forms. Magnesium 24, that means it has 24 protons. Magnesium 25, I'm sorry, I shouldn't have said protons. Let's back up. Magnesium 24 means it has 24 neutrons. Back up one more time. This number right here is the mass number. So magnesium-24 means that 24 is the mass number. 25 means that 25 is the mass number. Magnesium 26 means that 26 is the mass number. This is percent abundance. This is how much occurs naturally. So 78.99% of all the magnesium on the Earth exists as magnesium 24. That means it has 12 protons because that's its atomic number. 24 minus 12 is 12, so it has 12 neutrons. Magnesium 25 is only a 10% abundance. That means that it has 12 protons still, but 25 minus 12 is 13. So it has 13 neutrons instead of just 12. Magnesium 26 is the same thing. It's 11% abundance. That means that it has 12 protons and 14 neutrons. The mass of each one of those is going to be different because you have a number of particles inside the nucleus. One's 12 protons and 12 neutrons, and others 12 protons and 13 neutrons. Because of that extra neutron, it's going to weigh different. So to find that average atomic mass, we multiply the percent abundance times the mass for each one, for each isotope. Percent abundance times the mass, and then we add them all up together. That gives us our 29.31. So the formula for finding the atomic mass of an element is to have the percent abundance times the mass of that isotope, added to the percent abundance times the mass of the second isotope, and so on. Okay, let's look at another way to think of percent abundance is the same way that we determine your academic average. Your academic averages are what we call weighted averages. We say that our tests are worth 60%, or some honors classes are 70%. And then 40% of your grade is your quizzes, homework, notebook, whatever else, okay? So if you were wanting to find your academic average, you would add up all of your test grades. So let's say that your tests are, you made 100, an 85, and a 90. If I add all of those up together, that's 5, 17, 275, and then I would take 60% of that. Let's say now all of my quizzes, etc., were 100, 70, and 95. That's 16, 265. And then I would multiply by 0.4 because those tests are only worth 40 points apiece. So 275 times 0.60. Oops. $275 divided by 3. So that means my test average, let me erase this. My test average comes out to be a 91.67. My quiz average turns out to be an 88.33. But I don't just add those two together and divide by 2. That does not turn out to be my average. I take what I made on my test average, and multiply it by 60%, because tests are worth 60%. Then I take my quiz average, multiply it by 40%, because that's what they're worth. So 91.67 plus, or times, 0.60, 91.67 times 0.60 is 55.0. I add that to a quiz average, 88.3 times 0.40% is 35.32. When I add those two things together, I get my weighted average, 55.00 plus 35.32. And that gives me a weighted average of 90.32%. Well, figuring the average atomic mass is the same way. I take, here's my amount, my mass, or my amount of tests that I have. These are the amount of my quizzes that I have. I multiply them by the percent abundance, add them together, and that gives me my average. Okay? So on an element, I would take the mass of the isotope times what percent of the isotope I have and add all those up together. And you would be told these numbers. I don't expect you to be able to figure them out or to know them. You would be given the mass and the percentage, and then asked to find the average atomic mass. All right. Let's say that I have iron, and iron 56 exists 92% of the time. 92% of all iron exists as iron 56. And then you also have iron 54, and we only have 8% that exist. Iron 57, and 58 are all together 8%. So all three of those make up 8%, and 92% of it is iron 56. Okay? If iron 56 says determine the combined percentage of all the isotopes. So if you add the percentages together, that's 100%. 8% of them exist as 54, 57, and 58, all added together. And then you have one that exists as iron 56. And it looks like that's it. So we add up the percentages and the mass of each one of those isotopes, and you would get the average atomic mass of iron, which is 55.87. Okay, that is it for subatomic particles. Again, the main thing to remember is that there's three types. There's protons, neutrons, and electrons. Protons and neutrons are in the nucleus. Atomic number is the number of protons. It identifies what the element is. And the periodic table is arranged by increasing atomic number. The atomic number does not change. In normal chemical reactions, you will never change the atomic number of an element. Isotopes are the same element, but instead of having the same number of protons, they have different numbers of neutrons, and that causes them to have a different mass number. Mass number is just the sum of the protons and the neutrons in the nucleus, and it's not specifically listed on the periodic table, which is why we take the atomic mass and we round it. And you write the mass number as a superscript and the atomic number as a subscript when you're writing the symbol. Mass number is a superscript or on the top, atomic number is on the bottom or a subscript. So, for example, if I have S32, that means sulfur, and it has a mass number of 32. If I look up its atomic number, it is 16. To find the number of neutrons, I would say 32 minus 16 is 16. Another way is I can take hydrogen 1, 3. Subscript is the superscript is the mass number. The subscript is the atomic number. So that's going to wind up being 3 minus 1, which is 2 neutrons. And all of them are done that way. Let's look at one more. Chlorine, 35. Means I have a mass number of 35. So that would be 35 minus 17, because there are 17 protons. That's chlorine's atomic number. (15 minus 7 is going to give me 8. 2 minus 1 is going to give me 18 neutrons. Okay, that's it for today. If you have any other questions, make sure you ask me in class. Have a good day.